assignment. Now I will provide you some solution. Okay. Okay. This question is ask you determine whether the system described by yn equal to cos xn minus 1. Okay. Is memoryless or invertible or not, causal or not, stable or not, time invariant or not, or linearity or not. Checking first. Memory or not. Okay. You can see that in this case is not is a memory exactly. Never memoryless because it's a xn. The input is already in the time shifting version. Okay. X minus n minus 1. The system is memory because the system outputs yn is a function of the system input at the other time of the present time xn, and the the output is depend only on xn minus n naught. This means the output depend on the time shifting of the input version. Okay. The second one is invertible or not. If the function is already in the sine, cos, or tan or something like that, you know that okay is it non-invertible. Okay, because okay many inputs okay will be produce the same output. For example, if okay the cos minus omega equal to the cos omega, okay, therefore you can, for example, cos 90, okay, 90 degree equal to 0, right? Cos minus 90 degree is equal to 0 too. Therefore, when the input is come, you never know that what about the output is, input is, right? If you fix the output is equal to 0, the inputs may be 90 degree or minus 90 degree. You never know exactly. Okay. Therefore, in this case, if the function is already in the trigon form, it will be non-invertible. The system is non-invertible because the distinct system input xn may produce the same system outputs yn, such as the cos minus omega equal to the cos omega. Next one, the system is the causal because the system outputs depend does not depend on the input at the future time. Okay. In this case, is the way to classify them is causal or not is the same idea of the memory, but it will be in the time shifting and it must be n minus n naught. Okay. Here n naught must be positive or it will be this form. If it already in this form, it means it will be causal. Okay, because the output equal depend on the input from the history or from now. Okay. Therefore, in this case, you can summarize that the system is causal because the system output does not depend on the system input at the future time. Next one, the system is stable or not, or the BIBO stable because the system output is bound for all bound system input and can be proven here. You can check that. Okay. What about input is? Okay. If the maximum input is M, okay. You know that if it's M, we don't care for the input is, right? You know that the output of them, the output will be in the cost function. The cost function is have the range between -1 and 1. Therefore, the absolute of y will be less than 1 always, whether the input is, okay? Therefore, in this case, you can state that the output will be stable, okay? The next one is checking that the system is a time invariant or time varying by process them first, okay? If you process them, the output equal to cos xn minus 1, okay? And shifting them later, okay? Shift every n by n naught, okay? Or you will shift them first, okay? Shift them first and process them later, okay? You can see that minus n in this case. For this case, it will be fortunately that, okay, the output will be identical. It means the time invariant. The system is a time invariant because the system input xn minus n naught, that is the time shifted, produce the system outputs y n minus n naught, that is the same time shifted. The last one is for the linearity, okay? If you feed x1 to the system will produce y1. If you feed x2, the system will produce y2. Therefore, if you feed x1 to the system is y1 equal to cos x1 n minus 1. Okay. If you feed x2, output equal to y 2 equal to cos x2 n minus 1. Okay. If you fix x1 and x2 at the same time, okay, if you fix x1 and x2 is here, you can see that cos, okay, a plus b is here, you produce cos in this case, okay. What happened? The thing that you fix to here is not equal to the cos, right? Is by from the normal trigon law, okay. Cos a plus b not equal to the cos a plus with cos b. No, cos a plus b equal to cos a cos b minus sine a sine b, right? Therefore, it's not equal. If it's not equal, it means the system is nonlinear. Okay, nonlinear. Therefore, this equation is not true. Therefore, the system is nonlinear. The system is nonlinear because the system does not satisfy the principle of superposition of the additivity and homogeneity property. Okay. Now we will go to the next part. Okay, the LTI system. Wait a minute. Hello, can you see my slide?
Yes, Ajahn.
Okay. The next chapter is the Discrete-Time linear time invariant system, or the DT-LTI system. The key for the linear and the time invariant system is is the convolution. The system present, okay, this section present the system that have both the time invariant and the linearity property. Define the system described by the following block diagram. If you have the input xn, output equal to yn, or you can express them in the block diagram that show in the slide. The inputs, you feed the input to the system xn. The system have the impulse response hn, output equal to yn in this form. The system is a time invariant if a time shifted of the input result in the same time shifted of the output is. It means, okay, if you feed xn, output equal to yn, yes. If you shift xn by n naught, output will be shifting in the same manner. Okay, xn minus n naught, output equal to yn minus n naught will be shift in the same time. For linearity, if the system is a linearity, if the system satisfies the principle of superposition that we already described in the previous exercise. Okay. If you feed x1, output equal to the output of the system is y1. If you feed x2, output equal to y2. If you feed x1 plus x2, output equal to y1 plus y2. Even though you multiply by the constant, a1 and a2 will be multiplied in the same manner. If the system, in this case, you know that the system we have 6 properties, but we fix 2 first. Okay, we fix 2. If the system is a linear and it has the time invariant, we will consider in the special case, okay, the system that have the linear and the time invariant, so-called LTI. The several important reasons for analyzing the LTI system are as following here. In the general, many real physical systems can be modeled accurately by the LTI system, such as the digital filter analysis. The equations which are modeled from the LTI system for both continuous time system and the discrete time system are able to solve mathematically. Much information is available for both analysis and design of the LTI system. And for simplicity analysis, we can model and express mathematically a general input signal xn as a sum of the basic function x1, x2, x3 to xn. Okay. Consequently, the system output or the system response yn can be modeled as the sum of the response to each basic function that you express in here. y1, y2, y3, where y1 will be depend only on x1. y2 depend on x2, y3 depend on x3 respectively. Okay. The next we will discuss about the impulse representation of the discrete time signal, the convolution of the LTI system, the property of the convolution, the property of the DT-LTI system, the difference equation model and the term in the natural response. The first one is the impulse response of the DT-LTI system. This section presents how to express the general signal xn as the function of the impulse response. This form will be the same as the how to write the discrete signal in the mathematics equation, how to express them or how to model them in the mathematics equation in the impulse function. The first definition of the impulse sampling function or the unit impulse function will be shown you in here. The impulse function at any location depends on n naught. Okay, it will be equal to 1 at n naught and it equal to 0 to the other location. From the definition, the equation can be expressed as the following here. Okay, xn will be multiplied by the data function at that point equal to, when you multiply them, what happened? Every point except at the n naught will be equal to 0. Okay, except n naught. Therefore, only xn naught. Now, in order to give you more understand about how to write the signal in the mathematical form, from the signal xn that is shown in this figure, this signal xn have only 3 non-zero values. Okay, you can see that it have only 3 non-zero values. You write only non-zero location. Therefore, you require to use 3 impulse to represent them. The first impulse located at -1, the second impulse located at 0, and the last impulse located at 1. Okay, we model the first one first. Okay, the green one. What about the green one? Okay, you can write the green one. Okay, we can express the green one, x minus n1 equal to, here, you can see that you can write them in the impulse function form. Okay, impulse function. How to write them is give you the data functions. Okay, location at +1, right? At +1. The magnitudes of them equal to 2. Okay, equal to 2. Therefore, the green equal to 2 data n plus 1. Okay, 2 data n plus 1. Now for the next location at x0 is here. X0 is here. Is the data function and the magnitudes of the data equal to 3. Equal to 3. Okay. The last one will be here. Okay, will be here. The last one is the data function. Okay, and the data is okay. The impulse located at -1 data n minus 1. Okay, and the magnitude equal to, yeah, the magnitude equal to 1. Okay, about that point. Now, then we can express x1, x2, x3 in the term of here. X1, you can see that the data 1. Okay. Okay, you can see that we can write them in the general form in here. Xn equal to the data n minus 1, the green one. X minus 1 is the magnitudes of them. In this case, the magnitude equal to 2. Yes, equal to 2. You can express them in this form. Okay, I will write them in a little bit more detail for you. Wait a minute. I think we give you a little bit more understand. Okay. 2, 3, 1. Okay. Okay. Sorry for a little bit delay. I would like to create the PowerPoint that give you clearly understand. Animation print. Add the last one in here. Chip. Okay. 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 You can separate them. Okay. When you have the discrete signal, you separate to non-zero each element, x minus 1, x0, x1, separate them, okay? Each of them can distribute in here. You can see that the impulse represent the location at that point, data n minus n plus 1 in here, okay? The magnitude of them equal to 2, okay? Here, the second impulse, okay, is the data n, okay, location equal to 0, okay? And the magnitude of them equal to 3, The last impulse is here. The location is located at n equal to 1, okay? Therefore, the data is the data n minus 1, okay? The magnitude of them equal to 1 is here, okay? And therefore, you can write them in the general form of the summation here. And therefore, the general signal xn can be expressed at the following here. The summation of the impulse. Therefore, we can write them so easily. From my point of view, I think the way to write the discrete signal in the impulse function is very easy, or more easily than you write the continuous signal in the mathematics form. Okay. Next one is about the convolution for the DT-LTI system. What about the convolution in this case? The convolution, we try to track them from the discrete magnitude. Okay. In the continuous time, you fix one signal, flip one slide, and integrate them. The way to integrate is very, very difficult. But the discrete signal is a little bit more simple than the continuous one. This section presents the equation that related output signal and the input signal for the DT-LTI system. Defining the system described by the following block diagram, and the equations xn is yn is here. Xn is the input, the system function is Hn, Yn is here. Okay. For the DT-LTI system, okay, Hn is denote the impulse response of that, okay, is the impulse response is mean. If you feed the impulse as the input, output equal to that signal. It means, okay, output equal to the convolution between the input and the impulse response of the system. But in this case, the data functions is the identity of the convolution. Anything convolve with the impulse give you that thing. Okay. And if you shift them by a knot, output will be shifted by that same time. Okay. Now for an LTI system, the output Yn can be expressed as the convolution sum of between the input Xn and the impulse response of the LTI system, as shown you in here. Input is Xn, the system is Hn. Output equal to the convolution between Xn and Hn. The convolution sum of the Xn and the Hn can be defined by this operator and by this equation. Okay, you can determine them directly from this definition, or is have the cumulative property. Okay, Yn equal to X convolve with H, or H convolve with X. The impulse response of an LTI system Hn is a completely mathematically discrete input-output relation of the system. Now, in order to give you more understand about the convolution engine, I will provide you some example first, okay, and describe them in the graphical point of view. Okay, if the input is here, okay, you plot them first. Okay, the first one Xn equal to the data n minus 1, the first location. Second is the data n minus 2 at the n equal to 2, the magnitude is equal to 2, okay, and so on. Okay, now you convolve with that. Okay. Okay, in this case, we fix, okay, two signals, both of them is the same, close similarly, okay. How to fix them? You fix with non-zero signal. The Xn have 3 non-zero elements, but Hn have 4 non-zero elements. Therefore, you should fix S. Okay, okay, you should fix S. Okay, therefore, you process Xn. How to process Xn? You process each impulse of Xn. Okay, you can see that. Okay, you can see that. You consider only the orange one, Okay, yeah, this one multiplied with 2. Okay, 1 multiplied with 2 give you 2. 1 multiplied with 2 give you 2. Therefore, the result from the green will produce 4 impulse. Each impulse have magnitude 2. Okay, yes. The location of that. The location is the same of the green, but you shift in the right hand by 1 because the orange will be shift from the center by 1. Okay, therefore it's here. You can see that where it came from. Okay, the orange is identical to the, okay, is for impulse right edge. Okay, the magnitudes of them equal to 2 when you multiply them. 1 multiply 2 give you 2, 2, 2, 2. Okay, but the location, okay, in this case you shift green in the right hand by 1 position. Therefore we will produce here. Now the next one we will take them in the same manner. Okay, the blue signal. You can see that the blue signal. 2, the magnitude of blue is 2, right? 2 multiply 2 give you 4, give you 4, give you 4, give you 4. Okay, now the the result from this multiplication give you 4 impulse. Each impulse have 4 in magnitude. What about the location of the result? The location of the result is the same of Hn, but it shift in the right hand by 2 position. Therefore, the first will be located at 1. Yeah. The first located at 1. 4, 4, 4, and 4. Yeah. Now for the right one, the black one, okay, the magnitude of them is 3. Okay. 3 multiplied with 2 give you 3 multiplied 2 give you 6. 6, 6, 6. You have 4 impulse. Each impulse is have 6 in magnitude. Okay. The location of that, okay, the location will be the same as the green, but you shift in the right hand by 3. Therefore, the first impulse located at n minus n equal to 2. N equal to 2. Okay. 6 at 2. Okay, and 6 and 6 and 6. After you finish each multiplication, you add all of them. You add all of them. This is the result of the multiplication of the convolution result. Yeah. Now the next one, we will provide you another one example. Okay. Yeah. It's here. The first one, xn equal to, okay, 2, 2 minus 2 minus 2. Okay. Hn equal to 1, 2, 2, 1. Okay. Now in this case, xn have 4 non-zero, hn have 4 non-zero. You can fix either one. Okay, depend on you. Don't worry about that. Now if we fix, okay, if we fix h, we process x. Okay. Okay. The red one, the orange one is here. 2, 2 multiply 1 give you 2. 2 multiply 2 give you 4. 4 and 2. Okay. The location of them, in this case, xn will be located at the center. Okay, no shifting. Therefore, the result will be the same, identical to the location of h exactly. Start at minus 1, 0, 1, 2. Minus 1, 0, 1, 2. But the magnitudes of them will be double multiplied by 2. Okay, it will become 2, 4, 4, 2. Okay, for the second one is the blue one. Okay, the blue impulse is the same as the previous, but okay, 2 multiply 1 give you 2, 4, 4, 2. Okay, and the location will be shift in the right hand by 1 position. By 1 position. Okay, 2, 4, 4, 2. Yeah. Now the key is for the next, the third impulse is here. The third impulse equal to minus 2. You can see that minus 2 multiply 1 give you minus 2. Minus 2 multiply 2 give you minus 4, and minus 2. Okay. The location of them will be shift, make the green will be shift by 2 position in the right. Therefore, the first impulse will be located at, shift by 2, located at n equal to 1. 2 minus 4, 2. Okay. The last one is the white blue. Okay. The light blue is here. The light blue is minus 2 the same. Okay. Minus 2 multiply 1 give you minus 2, minus 4, and minus 2. The location will be shift from the green by 3 position in the right hand side. Therefore, the first location move from minus 1 to be 1, 2, 3. Locate at 2, n equal to 2. 2 minus 2 minus 4 minus 4 minus 2. You sum them, you sum with each side. Okay, here the result is here. You can see that in this case we have plus 6, we have minus 6. Therefore, at this point equal to 0. Okay. So, okay. The question number 1 in the book. Okay, let's do it now. 1 and 2, okay, and I will provide you solution. Can you listen me? Hello?
Yes.
Okay.
Yes,
okay. Let's do it. Okay. And during that time, okay, open the camera. I will check your attendance. Okay.สุบนัทวันนี้มาซูมใกล้เลยเว้ย
อยู่ข้างนอกครับอาจารย์มารับรถ
โอ้มีปิ๊บปิ๊บปิ๊บปิ๊บด้วยโอ้โหยังว่าอยู่มาใกล้เลยใช้มือถือเลยโอ้ยไม่ต้องซีเรียสขนาดนั้นถ้าเองออกไปธุระเดี๋ยวก็โดนรถชนหรอกเองกลับมาดูวิดีโอก็ได้ก็บอกเหตุผลที่ต้องขาดว่าไปส่งสาวอาจารย์ก็ไม่ว่าอะไรหรอกเข้าใจฮะหน้าไปส่งสาวไม่น่าอายถ้าเองต้องไปส่งหนุ่มเนี่ยค่อยอายเพื่อนหน่อย เป็นไงรัชตะวันเป็นไงพอทำได้ไหมเราแหละ
ข้อนี้ก็ทำได้
พอได้นะแกะไปรัตพลล่ะพอไหวไหม
ทำได้ครับทำได้ค่ะ
ปิยธิดาเป็นไงบ้าง
ค่ะ
พอทำไหวไหม
พอได้อยู่ค่ะ
หรือโจทย์ง่ายไปข้อสอบต้องยากกว่านี้20 เท่า
ไม่ค่ะ
Hi what did we all are you okayชิ้นอารมณ์ล่ะเป็นไงบ้างชิ้นอารมณ์นี่อยู่ปะเนี่ยสงสัยไม่อยู่หลับไปแล้วOkay, I'm going to drink a little. Okay, 1 minute and we came back. I'm back. Okay, if you have any question, you can talk to me. Okay. Anyone finished yet? The first question is not finished yet. I think it's too easy. Okay. Quickly, I will provide you more time. Okay. Another 5 minutes. Okay. Quickly. แล้วชัตวันมี supply ด้วยเหรอ มีคูเรียมาส่งน้ำนะมีส่งคูเรียมาส่งน้ำด้วยเหรอ มีอย่างนี้ด้วยนะ
ค่ะ
ไม่เป็นไรป่ะรีบทำเดี๋ยวจะเฉลยให้I will give you another 5 minutes and I will provide you solution. Okay, and we will continue to the next part. Okay. Hello? Anyone can hear me?
yes ค่ะ
Okay. The solution of the first two questions is provide you the practical exercise for the convolution operator. Okay. The xn is here is have okay 5 non-zero 3 3 and another one 3 impulse is here. Okay. Is the hn is 5 okay. Okay, 5 is non-zero impulse. Okay, in this case you can select okay picks either one. Okay, in this case if we is okay holds is hn okay and we process for the xn the first impulse equal to 3 okay equal to 3 multiply with 2 3 multiply with 2 give you 6 we have about a 5 impulse with 6 in magnitudes. Okay, 5 impulse, 6 in magnitudes. Okay, the location will be the same, identical to Hn. Start from 0 to 4, 0, 1, 2, 3, 4 is here. The second operator is here for the blue impulse. 3 multiplied with 2, the same as the previous, except the location of them will be start at 1. Okay, it will be start at the same at the green and it shift in the right hand side by 1. Therefore, the result will be start at 1. 6 start at 1. 6. We have 5 impulse start from 1, 2, 3, 4, 5. Each impulse is have 6 in magnitudes. The next one, the black one is here. 1 multiply with 2 give you 2. Okay. It have another 6 impulse. Okay, sorry, it have the 5 impulse. Each impulse have 1 in the magnitudes. The location of them will be start at 2. Start at 2. Next, okay, the blue, the white blue, okay, the light blue. 1 multiply with 2 give you 2. We have another 6 impulse, another 5 impulse. Each impulse have 1 in magnitudes. The location will be start from 3, 4, 5, 6, 7. Okay, start from here. The last one is the green. The green is okay, the dark green. Okay, 1 multiply with 2 give you 2. Okay, give you 2 in magnitudes. Okay, this will be in here. Sorry, 1 multiply with 2 give you 2, 2, 2, 2, 2. Okay, sum them provide you about here. Okay. Next one, the second exercise is here. Okay, we plot them first. Okay, it's 2, 1.5, 1, and 0.5. Okay, 2, 1.5, 1, and 0.5. Okay, this case is the same. Okay, Hn is the same as the previous one. Okay, 1, 2 multiply with 2 give you 4. Give you 4, 4, 4, 4. Okay, we have 5 impulse with 4 in magnitudes. Okay, next one is 1.5. 1.5 multiplied 2 give you 3. 3. Okay, the blue is 3 is here. Okay, we have okay 5 impulse. It have the 3 in magnitudes and the location will be starting at 1. Okay, the green is starting 1, 2, 3, 4, 5. We the same as the green but shift in the right hand by 1 position. Next one is okay the black one. Okay, the black 1 multiplied with 2 give you 2. Okay, we have 2. We have 5 impulse. Each impulse have 2 in magnitudes. And the last one is 0.5. 0.5 multiplied 2 give you 1. Okay, 0.5 multiplied 2 give you 1, 1, 1, 1, and 1. Okay, we have 5 impulse. Okay, the magnitude is 1 for each. Okay, sum them, give you here. Okay, it's not difficult. Okay, now we can review about the detail of the property of that. Okay, next one is the property of the convolution and the property of the DT-LTI system. The property of the convolution is the same as the property of the continuous time convolution. For the discrete time, the same. We have the cumulative okay, property. The convolution sum is the symmetrical with respect to xn and hn. It means you can x convolve with h, or you can use compute h convolve with x the same. For an DT-LTI system block diagram point of view, the cumulative property can be illustrated as the following figure. In the block diagram, it means if xn is the input, hn is the output, okay, output equal to the convolution between the input and the system itself. In the mathematics point of view, it seems that you can sweep, okay, you can change the location of the input and the system, okay, process by the input and the system by here. But in the real world, you cannot. Remember that the real world, the system is something touchable, such as the amplifier circuit, the feedback circuit, the controller circuit, or something like that. It's a circuit. It's not a signal that you capture in the air. Okay. Therefore, you cannot change them to be the signal directly. But in this idea, can implement in the mathematics formulations idea. Next one is the associative property. The associative property is the result of the convolution sum of the three or more functions is independent of the order in which the convolution is performed. Okay. Xn is here. If you must take three convolutions, you can take either two first. Okay. For example, you can take x and h1 first. Okay. Or you can take the h1 and h2 first. Or you can take okay h2 and h1 first. Depend on you. You can process or you can compute either first two. Okay. For an DT-LTI system block diagram point of view, the associative property can illustrate in the following block diagram. Okay. The associative is mean you okay, the original idea is here. You have the first system H1, you have the second system H2. You feed the input to them. Okay, the input will be processed with the F1 first, and the output that you completely processed from system 1 will be sent to the system 2 and processed at the system 2 produce the total output. Okay, but for this idea is only in the physics world and the mathematical relationship. In the mathematics model, you can sweep here. Okay, you can see that you can process the second block first and process the first block later. Yes, this idea is only true for mathematics idea, but it's not true for the physics idea. Why? For example, if H1 is the amplifier, Xn is the signal that you receive from, you generate from the microcontroller, will be produced about a few milliamp. Okay, you require to amplify the signal by the amplifier first, okay, and by H1 before you drive them to the motor. Okay, H2 is the motor. I would like to ask that it is possible that you feed a few milliamp to the motor directly and you try to amplify them later. No, right? It's no. Therefore, this idea is true only in the mathematics idea, but it's not true for the physics idea. Moreover, okay, this idea is here. Or you can convolve, you can merge between the block 1 and the block 2 to be a single block, a very big one. Okay. In the real world, yes. Okay. In the real world, it's impossible to merge the amplifier and the motor to be a single piece? No, it's impossible, right? But you can see them right here, a bigger block diagram. Okay. But in the real physics, you cannot merge them. Okay. It's about this idea of the associative property. Okay. Next one is the distributive property. The distributive property of the convolution sum will be certified here. You convolve between two signals. Okay. Xn, you can see that Xn is maybe the input. Okay. H1 and H2 is the output. Okay. That cascades together. Okay. The result will be here, convolve with the sum of them first. For the DT-LTI system block diagram point of view, the associative property can be illustrated as the following figure. Okay, X1 you feed to the system 1 here and feed to the system 2 and you add the result here. Okay, in the overall point of view, you can merge between system 1 and the system 2 together. Okay, and you will produce the output in this form. Okay, remember that all property you can apply them, but you cannot reorder to decide them in the block diagram point of view because it's impossible to change the physics worlds, okay, to be a single piece or to split them to be 2 or 3 parts, okay. But in the mathematics, it can facilitate your computation. make your computation is more faster and more easier. Okay. Next one is the property of the DT-LTI system. For the DT-LTI system, for the property of the system, we have 6 properties: the memory rest, the invertibility, the causal and stable, time-invariant, and the linearity. But in this section, the system is already specified by 2 main properties, linear and the time-invariant. In the previous section, we present the several properties of the discrete-time system, such as the memoryless, the invertible, causal, stable, time-invariant, and linear. For the DT-LTI system, we investigate the another 4 properties, okay, the memoryless, the invertible, the causal, and the stable. For the DT-LTI system, can be completely described by the input-output characteristic by the impulse response. Therefore, all property of the DT-LTI system can be determined from the impulse response too. The idea is the same of the continuous time. The first one, you can checking that the system is a memory or not by you observe or you analyze the impulse response of the system. If the system output at the time and naught or y and naught depend on the system input value other than x and naught, or is the time shifting version of input, then the system is memory. Otherwise, the system is memoryless. Therefore, an DT-LTI system is a memoryless if and only if the HI will be in the impulse function form. Impulse is mean in memoryless if it's 0 everywhere except at n equal to 0. At n equal to 0, it can be any value. We don't care. Maybe positive, maybe negative. We don't care. Yeah. If it's already in this form, we call them memoryless. Okay. Here, you can see that due to, okay, for n is not equal to 0, for n equal to 1, 2, 3, 4 is non-zero. Therefore, the system is memory. The memory is causal in this case. Okay. There is, okay, for n not equal to 0, n equal to 1, 2, 3, 4 is non-zero. It's memory. Okay. Now, but it's still causal. For this case, it's non-zero. No place, that's 0. Okay. Therefore, Hn for the last class, it will be memory too and non-causal. Okay. Next one is the invertible. If the distinct system input xn produce the distinct system outputs yn, then the system is invertible. For the invertible system, the system input xn can be determined uniquely from the system output yn. And the DT-LTI system, the system is invertible if the input xn can be determined from the outputs. Okay. In general, we can compute this process by apply the Fourier transform or the Laplace transform. The Fourier is the discrete time Fourier. It means you might have, okay, you send the input to the system and you can create the inverse system that cascades for the first one and will produce the input back again. Okay. It means you can find Hn that convolve with the system, the inverse system that give you the impulse function. Okay, the impulse function. Therefore, the way to compute them in time domain is very difficult, but the way to compute them in the discrete Fourier transform domain or the set domain is considerably easy. Therefore, the DT-LTI system that have the impulse response Hn is invertible only if the impulse response Hi can be determined that satisfy the above equation. But in time domain, it's very difficult to find. Okay, we figure it to determine them in transform domain, Fourier Laplace set domain of transform. Okay, so on. The next one is the causality. If the current value of the output depend only on the current and the past value of the system input, then the system is a causal. Otherwise, the system is state non-causal. It means, hence, the causal system must have the impulse response 0 for n less than 0. Okay, only here. We observe only here. If n less than 0 is equal to 0, for n greater than or equal to 0, it can be any value. We don't care. Okay, causal. Next one, for n less than 0, it equal to 0. Yes, it's causal. Yeah. But for this case, is memory or not? It's memory. It's memory. Yeah. Next one, This thing is the same. Okay, for n less than 0, it equal to 0. Yes, therefore it is a causal. Okay, but due to for n greater than 0, it not equal to 0, right? It have some non-zero. Yeah, therefore it will be memory. For this case, for n less than 0, it's not 0. Therefore, it's non-causal for this case. Okay. Next one, and the last one is the stability. If the system output yn remain bound for any bound system input xn, then the system is called the BIBO stable or the bound input and the bound output. Okay. Hence, the output Syn is a bound if it satisfies the following equation. This means the equation is not too complicated. If you see them deeply in this equation, it's very simple. Take the absolute. It means if the impulse is negative, make them all positive. And after that, you summation all impulse. If all impulse is not infinity, it means it's stable. For this case, Hn in this case, the summation of them equal to 1 and 0 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 and 0. Therefore, the sum of them equal to 1. 1 it means stable. Yes. Yes. For here, 1, 1, 1, 1, 1. Okay, how many impulse we have? Infinity, right? 1 multiply infinity give you infinity, therefore unstable for this case. Yeah. For here, in the okay, you can use the geometric summation in here. Okay, the decaying exponential in here. The summation operator, we can prove that this thing is stable. Yeah. But here, this thing is the 2 times of the left-hand side club. Therefore, if this club is stable, this club is stable too. Yeah, you can see that. Now, when you're checking again, this stable. This system is memory or not? Yes, it's no. It's memoryless. It's memoryless. Okay. This system is memory or not? It's memory. It's memory. It's memory. Now we're checking again. This club is causal or not? Yes. For time, for n less than 0, it equal to 0, stable. Oh, sorry, causal. Sorry, causal. This thing is causal or not? Yes, it's 0. Causal or not? Yes, it's 0. Causal or not? No, it's non-causal because it's not equal to 0. Okay. Now, okay, try to do, okay, the rest, okay. Exercise, wait a minute. Now, can you see the homework?
Yes.
Okay.
Yes.
3 to 5. Okay, let's do it. Okay, and the next time of the lecture, I will provide your solution. Okay, any question?
No.
Okay, see you next
No,
time.
ค่ะ
Good luck.
See you, teacher.
Thank you.
Thank
Ajahn.
you
Thank you
ค่ะ
thank you
สวัสดีครับ
Thank you. Thank you ค่ะอาจารย์
ครับผม
สวัสดีครับ
สวัสดีครับ